Okay, in this video we're going to remind you about something that a lot of you have heard of or seen before. It's called the Pythagorean Theorem. And the Pythagorean Theorem is something that's very useful for measurements in right triangles, but only in right triangles. Okay, so you have to make sure that you don't do this in things that don't have a 90-degree angle. Now, what we usually see is something like this. Let's just write out something generic. A squared plus b squared equals c squared. And a lot of people look at that and say, I don't even know what that means. I'm not sure where to start. Okay, well, in terms of geometry, what we're saying is, let me see if I can color code this. Side A is like this over here. That's 3 units. Okay, there's side A. Okay, and then we've got side B. Side B, we don't happen to know. Okay, side B is down here, and we don't know what that measurement is necessarily, so we can just see that it happens to be longer in this case than A. And then we've got side C, and side C, the one that's by itself, notice it's on its own side of the equation, that's always the hypotenuse, the longest side. And right here, this is side C. We've got the longest side right there. Okay. So that's what this thing is representing. Now, what it means is anytime we have something we don't know, in this case, we don't know this side here. In a right triangle, if we have a side we don't know, this relationship will always help us figure it out. Now, sometimes it's not a nice whole, simple to use number. Sometimes it's a decimal, but that doesn't matter. Okay, now, how can we do that? How can we use this to help us? Well, let's plug in the numbers we do know. Side A, that's our shortest side. Side A is 3, so I'm going to write 3 squared, because it's got a squared there, plus b squared, because I don't know b, so I'm just going to leave b there, equals c squared, and c squared happens to be 5. Okay? Now at this point, let's try to write it a little bit better. Let's clean it up a little bit. So 3 squared, that's not 6, it's 9. 9 plus b squared equals 25. And what we want to do is we want to solve for this b, this thing that we don't know. We can figure out that other side every time by doing this. So I'm going to take 9 and I'm going to subtract it since it's positive. And I get b squared equals 16. And I haven't solved for b yet. I still have to take the square root of that. So I get b equals 4. Okay? Now that tells me this side should be 4. And in this case, I set it up so that it would come out to be a nice whole number. Okay, but it doesn't always work that way. A lot of times these are going to be decimals, and that's okay. It doesn't mean it's wrong. What you do need to recognize, though, is that this answer, any one of these sides that's connected to the right angle, has got to be shorter than 5. 5 is my hypotenuse. So if I got an answer of 6 down here, something went wrong. Okay, I've got to know that I'm looking for something that's got to be shorter than the hypotenuse. So you always want to double check that at the end. And the reason we're going over this now is a lot of times you're going to get drawings that you try to find, say, the area of, and they don't give you this little distance right there. So you might know this distance here is 10, and this distance up here is 13, and you might need to find that distance right there in order to figure out the area. So the Pythagorean Theorem is going to show up a lot. It's one of those things, it's just another tool that we just use all the time. You've got to get proficient in it. You got to get to where you do it without even really thinking about it. So there's an example of how you would set that up.